is the tutorial for Chapter 5, Section 3, Chapter 5, Section 4, reviewing solving systems by elimination and also some special systems. So let's take a look at our first problem here. We have a system of equations, but notice the x's and the y's are not lined up with the constants, but the equal signs are. So when we use elimination, we always have to have the y's and the constants on lined up. So what I'm going to do is just switch some terms around. So whenever you switch a term, you're basically doing an opposite operation. So I'm going to move the 3y over by taking it away, but I'm also going to subtract the 3 from all sides. That'll eliminate this 3 and eliminate the 3y, but notice how the negative 3y is now on the left-hand side of the equal sign. The negative 3 is on the right. So it becomes 3x minus 3y equals negative 3. On this side, this one's all set up for us. It's just 2x minus 6y equals 2. But now I need to modify these so I can get either the x's or the y's to cancel. So let's say I went ahead and multiplied this one by negative 2, and that'll make it a positive 6y here. So this becomes negative 6x plus 6y equals positive 6. Well, this other equation is 2x minus 6y equals 2. So when I go ahead and add them together, I end up with a negative 4x. The y's cancel out, and I have 8. So x equals negative 2 when I do that division of negative 4 on both sides. So I'm going to take that negative 2 and substitute back in, put it into this bottom equation here. So I have 2 times by negative 2 minus 6y equals positive 2. So when I do that work, I get negative 4 minus 6y equals 2. I add the 4 to all sides, and I've got this. I got negative 6y equals 6. So when I do that division, negative 6, I end up with y equals negative 1. So I can write the point as an ordered pair, negative 2 and negative 1. That's where the two lines cross. So on this next one, though, again, things aren't lined up, so let's line them up. Let's move the 4y over to the other side. And actually, notice how I can just switch this around, move everything around. And if I did that, kind of just turn this around, and I don't even have to switch anything because I'm turning everything around. So 4y equals 2x minus 6, and that's the same thing as just having the 4y on the left-hand side or the right-hand side. It's kind of like saying this. If I had, let's say, x equals 2, that's the same thing as saying 2 equals x. So if everything needs to switch, then you don't have to switch the signs. So now I could go ahead and use the elimination method. So I'm going to go ahead and multiply this bottom equation here by 3 and the top equation by 2, and that'll cancel out the x terms. So when I do that, I've got 14y equals negative 6x plus 18. This side, I end up with 12y equals 6x minus 18. So when I go ahead and do some work there, I end up getting the x's to cancel, but I also get the 18's to cancel. So I'm left with 0 equals 26y. So the only number that would make that the case is y equaling 0. So that's good. So it doesn't make a no solution or an infinitely many, because notice how we still have a variable. It's only when the variables all cancel where we'll have one of those answers. And so we'll see that next time. So we go ahead and take that y and substitute in for one of these y's over here. So I'm going to put in for this y here. So I've got 2x minus 6 equals 0. And then all I have to do is move the 6 over. And I've got 2x equals 6, and I'll go ahead and divide by 2. X is 3. So when x is 3, y is 0. That's where the two lines cross. Let's take a look at another set of problems here. We've got another set of systems that's good for substitution. So I'll take this 5x minus 9 and substitute into this other y here. So I've got 5x minus 9 equals 5x plus 9. So notice how I go ahead and subtract 5x from all sides, and I get the x's to cancel. And this is a situation where we don't have a solution because we don't have an identity. So these numbers don't equal. So this is a no solution. So what no solution means is the lines do not cross. And if the lines don't cross, that tells us that we have parallel lines. So the lines are parallel. So let's take a look at the next situation here, and we can go ahead and use substitution once more. I could take this 8x minus 2 and put it in for y. So when I do that, I've got 8x minus 2 minus 8x equals negative 2. So when I collect these two terms, I end up getting 0. And I cancel out that term. And notice how I end up with negative 2 equals negative 2. That's an identity. And so when you get an identity, that tells us something. Typically on some problems when we're verifying a points on a line, we'd say, oh yeah, the points on the line. But here we're getting identity with a system. And so what this means is we have the same line. So if I went ahead and solved for y on that bottom equation, we'd end up seeing it's 8x minus 2. So when I have the same line, that means there's infinitely many solutions. So let's take a look at the next problem here. On this problem, we're asked to find out what the values of x and y are on this rectangle. And so let's take a look at the first one here, and it says that the rectangle A has a perimeter of 36 units. Rectangle B has a perimeter of 108. So we're supposed to solve and write a system to find x and y. So perimeter is this. It's 2L, 2 times the length plus 2 times the width equals the perimeter. So we could go ahead and double the length and double the width. So I can write 2 times by, and then 4y plus 2 times by 2x, and that'll equal 36. And so when I go ahead and set up the next one, do the same sort of thing. This is a 12, we'll say right here. And so I have 2 times by 12y plus 2 times by 6x, and this all equals 108. And so when I go ahead and solve this, I'll multiply out these numbers, and that gives me 8y plus 4x equals 36. And on the next one, I get 24y plus 12x equals 108. And so I'm going to go ahead and multiply this equation here by negative 3, and when I do that, I end up with this. Negative 24y minus 12x equals negative 108. I did that to try to cancel out the y's because I saw 8 times 3 makes negative 24, or 8 times negative 3 does, and I ended up canceling everything out. So I got this situation. What this means is that we cannot determine the value of x. So we can't determine x or y because there's infinitely many solutions. So there are infinitely many solutions. There's so many we can't even count them because we have the same lines. The lines are the same. The lines are the same. We have the same equation in this case. And so that would be the reasoning there. So let's take a look at the next one. And here it says the table shows 2 activities. 2 visitors are at a park. And it says you want to take a boat tour for 2 hours and a walking tour for 3 hours. Can you determine how much you will pay from this situation? So we've got to come up with some variables. I'm going to use B equals the amount for a boat tour, the cost of a boat tour, and that is per hour. And we'll say W equals the cost of a walking tour per hour. And so let's go ahead and set it up. I've got 1b plus 2w equals 19, and the next one's going to be 1.5b plus 3w equals 28.5. And so I'm going to try to cancel out one of these terms. I'm going to multiply this bottom equation by negative 1.5, and that's going to cancel out the 1.5b here. So I get negative 1.5b, but I also get, when I double 1.5, I get a negative 3w. And just so happens 19 times by 0.5 equals negative 28.5. So we have the same scenario as the last one. So when we go ahead and do the work, we get another infinitely many solutions. So what we'll say is we can't determine the price because because there are an infinite number of solutions. And the reason is the lines are the same. So those are the types of problems that you're going to see on tonight's assignment. Good luck.